What is the stack? The stack is a special region of the process memory that stores variables created by each function. The memory for each function is called a stack frame, and this is where our local variables live. For every function call, a new stack frame is allocated on top of the current one. Only the function that created the stack frame has access to it. This is what gives scope to our functions. The size of every variable on the stack has to be known at compile time. If we want to store an array on the stack, we have to specify exactly how many elements it will hold. When a function exits, its stack frame is released. This means that we don't have to worry about deallocating the memory, it is managed for us. Let's see how the memory layout would look like for a simple program like this one. Because we have not encountered Rust syntax yet, this is written in some simple pseudocode, but it is pretty clear what it does. We have a main function. In this function, we create one local variable that is of a type integer, and we assign the value 2 to it. Then we call the stack-only function that is defined down here, passing the local integer. And we can see in the stack-only function, it accepts one parameter that is of type integer, and it creates another local integer on the stack. Let's see what would happen when we run this program. First, we need a stack. We would start from the main function, and a stack frame for the main function is allocated. After that, the local variable a is put on the stack. And we can see that the size of the stack frame for the main function is just big enough to hold the only variable that it has to store. The compiler was able to calculate the size of the stack required for this function at compile time. Then we call the stack-only function, and we see that a new stack frame is allocated on top of the previous one. It's also interesting thing to notice that the stack frame for the stack-only function is larger than the stack frame for the main function. The reason for this is that the stack-only function has to store two variables on the stack, the parameter b and the local variable c. After that, we would store the value for the c variable on the stack, and the stack-only function is ready to exit. Once the function exits, its entire stack frame is released, and this memory is deallocated and can be reused. And when the main function goes out of scope, its stack frame is also released. It's important to remember that the stack has a limited size, and this size is determined by the machine architecture, operating system, compiler, and other factors. If we reach the end of the stack by an infinite recursion, for example, our program will crash with a Stack Overflow error. Let's see how that would look like. Here we have a simple recursive function called infinite that just calls itself. To execute this, again, we need a stack, and we enter the infinite function and we allocate a stack frame for it, and then we keep allocating new stack frames on top of the previous ones for every invocation of the infinite function until we run out of stack space and we get a Stack Overflow exception.